it's, I don't know if it's there. It gets to the point where I put up this article, and it's called Extraordinary Biological Observations. And I wrote about one paragraph on it. It's like I didn't want to say too much, but I had to say something. And what it was about, let's see if we can, I'm going to try and push into those.
Morgellions.
Pardon me? The art world?
Microorganisms being sprayed in the aerosol.
And when we do finish today, I don't have that. Yeah, I want to get to it. Well, nevertheless, what happens is I'm starting to play with cultures. I'm starting to collect these air samples, and I'm starting to create a culture dish, a medium where you try to grow things. Everything I do is jury-rigged with equipment. I mean, I do it proper the best I can, but I don't have like a formal lab. I just do the best I can. But I started getting involved with culture. And I had this situation come up where, number one, I've seen these structures that look like they're an erythrocyte. And there is a twist to this, by the way. And the twist is, it appears as though the original form of these, and by the way, this is what the professional medical person concluded also at the very beginning, was that these appear to be desiccated. That's the word he used, okay? Freeze-dried. These are reduced in size. These are not like you just see a blood cell just popping around. It's like some kind of core structure that is impervious to adverse environmental conditions, would be the way I would say it. But then under the proper medium and environment can be reconstituted. And that was actually his big move. He called me down there because he had been playing around for either weeks or months trying to see if he thought that these things looked like red blood cells, but he knew they were smaller than they should be. So he spent a great deal of time trying to see if he could come up with a reconstitution method of some kind. And he did, and that's when he called me. It was when he had a method of reconstituting, and that's when I went down there. Well, I got involved with cultures on my side, and I took these air samples, which had these apparent erythrocytes, and I started forming these cultures, and I had some really dramatic and immediate growth that took place. And like I would have done this several times and not say a word, because this is like really getting out there in terms of what's going on here. Because when I put these cultures under the microscope, it's like I had a zillion cells. And not only that, they were reconstituted, like they were at the right size. Okay? They just were. And I put up this paper called Extraordinary Biological Observations, and I wrote like one paragraph. And it's like, I don't know how to say it. No, nobody came after me. Okay, it's just that this was so important and so profound to me in terms of what's happening. Here's the problem, folks. You don't grow red blood cells in a test tube. You don't grow red blood cells. This is like the holy grail of biological research, is to be able to grow. I'm going to take questions afterwards. It's like the greatest achievement of current biology would be able to create blood cells. You just don't do it by conventional science. It's not under our purview right now. Now, there are some leads and suggestions, right, that there are some things going on that indicate that this is a very, very active field of research and that we would love to be able to do this. But in terms of the formal literature, do you have anyone saying at all that this could be done? Well, no. And not only that,